Section 1.8 gets at the concept of absolute values in equation form and in inequality form. This should be a review of your pre-college math experiences, but just as a review, we're going to look at each of these types of problems. First with equations. And with equations, we're going to look at the example that the absolute value of some number is equal to 3. And think about what possible values could go into an absolute value to give us a solution of 3. Well, we know that the absolute value of 3 is 3, and the absolute value of negative 3 is 3. In other words, we've got two possible situations for what can go inside the absolute value, both the positive and the negative. So we're going to need to solve an equation for both the positive and the negative. Before we do that split up, though, there's an important first step we need to remember, is we first must isolate the absolute value. Then we will consider the plus or minus, the positive or the negative. So for example, if we've got the absolute value of 3x minus 4 equals 7, the absolute value here is completely alone, so all we need to do is consider what values inside the absolute value could give us a 7, which would be either positive 7 or negative 7. So 3x minus 4 might equal positive 7, or 3x minus 4 could equal a negative 7. And then the absolute value would make it positive. In other words, the way we remove an absolute value is by considering both the positive and negative solutions. So to solve then, we add 4 to both sides in the first equation. 3x equals 11. And then divide both sides by 3 to find out x is 11/3. The second equation solves exactly the same in this case. We're going to add 4 to both sides. Gives us 3x equals negative 3. Divide both sides by 3, and x could equal negative 1. So our two solutions here are 11/3 and negative 1. Let's look at a bit more of an involved problem, though. Let's do negative 2 times the absolute value of 5x plus 3 plus 6 equals negative 4. Now this problem's a little different, and the common error we see students do is they will rewrite this with a positive 4 and a negative 4. And that is incorrect, because that process gets rid of the absolute value, but the absolute value here is not alone. We've got negative 2 times the stuff plus 6. We have to get rid of that negative 2 times the stuff plus 6. And so just like solving other equations, we'll first get rid of the adding and subtracting by subtracting 6 from both sides, leaving negative 2, absolute value of 5x plus 3 equals negative 10. And then finally get the absolute value alone by dividing by negative 2. And when we do, we have the absolute value of 5x plus 3 equals positive 5. Now that the absolute value is alone, now we can consider the two equations, stripping off the absolute value. 5x plus 3 equals 5, and 5x plus 3 equals negative 5. And solve these equations. Subtracting 3 from both sides gives us 5x equals 2, and dividing by 5 gives us x equals 2/5. The other equation, solving the exact same way, subtracting 3 gives us 5x equals negative 8, and dividing by 5 gives us x equals negative 8/5. And we have our two final solutions. So in summary, absolute value equations get the absolute value alone, and then strip the absolute value by considering the positive and negative solutions. That's really all there is to equations. A few more things to look at, though, when we're talking about inequalities. Let's kind of set this up by saying the absolute value of a number is less than 2. And I want to recall what this really means. A lot of the times we get distracted with absolute value by saying, make it positive. But that's not really what absolute value means. Absolute value means the distance from 0. So what we're really saying with this inequality is that the distance from 0 is less than 2. In other words, if I have a number line here with 0 in the middle, 2 and negative 2 out to the sides, we want to know where is the distance from 0 less than 2. Notice this entire blue line, anywhere along that blue line, has a distance of less than 2. So we're going to be actually between negative 2 and 2. In interval notation, negative 2 through positive 2. This is what we're going to use in order to solve our absolute value equations. When we see that the distance is less than 2, we will say A is between the positive 2 and the negative 2. Notice the negative goes on the left. That's important. The small number first. So if we were to work an example, say the absolute value of 3x plus 5 is less than 4, we know that means the 3x plus 5, because it's less than, has to be between negative 4 and positive 4. Then we solve from here. When we subtract 5, we have to subtract 5 from all three parts, giving us negative 9 is less than 3x, which is less than negative 1, and then divide each part by 3. And x is between negative 3 and negative 1/3. In interval notation, we go from negative 3 to negative 1/3. Anything in that range will make this inequality a true inequality. Let's try another example. How about we do the absolute value of 5x plus 1 over 2 is less than or equal to 3. Again, because the absolute value is less than, we'll say 5x plus 1 over 2 is between, with the or equal to, negative 3 and positive 3. We can start solving by getting rid of the fraction by multiplying everything by 2. That'll divide out in the middle, leaving us negative 6 is less than or equal to 5x plus 1, which is less than or equal to positive 6. Subtracting 1 from all three parts gives us negative 7 is less than or equal to 5x, which is less than or equal to 5. And finally, dividing by 5 to get the x alone gives us negative 7/5 less than or equal to x, less than or equal to 1. Or in interval notations, with square brackets, because we're or equal to, we're between negative 7/5 and 1. Let's try one more example that might be a little bit more involved. How about we do 4 minus 2, absolute value of x plus 1, is greater than negative 2. again, just like with solving with equations, we don't like to see the absolute value hanging out with a bunch of other stuff. We need to get that absolute value alone before we decide what to do with the inequality. We can get it alone by subtracting 4 from both sides, giving us negative 2 absolute value of x plus 1 is greater than negative 6. Then we can divide both sides by negative 2 to get rid of that 2 in front, giving us the absolute value of x plus 1 is less than, remember when we divide by a negative, the inequality flips over, 3. I want to notice a couple things we did as we got that absolute value alone. First thing, we did not do 4 minus 2 to get 2. We can't combine them because they are not like terms. The 2 has an absolute value on it, the 4 does not. Not like terms. Another thing I want to notice that we did is we did not distribute the negative 2 through the parentheses. We will never, ever distribute through absolute value, because distributing could potentially change the sign and as a result change the solution. Always divide out a coefficient in front of the absolute value. And thirdly, very important, when we divided by a negative, the inequality flipped over. Don't forget when we divide by a negative to switch the inequality. Now we have the absolute value is less than a number. We know when the absolute value is less than a number, it means it's squeezed between the negative 3 and the positive 3. And we can solve this equation quite nicely by subtracting 1 from all 3 parts, giving us negative 4 is less than x is less than 2, or an interval notation with a curved bracket, because it's just less than, we're between negative 4 and 2. So when the absolute value is less than a number, we set up this tripartite inequality because the distance is less than 2. It's between 2 numbers. That's different than if the absolute value were greater than 2. Because now we're saying the distance from 0 is more than 2. And so if we were to think about that on a number line, we want distances that are greater than 2 away from 0. That'd be from 2 up. Those all have greater distances. Or from negative 2 down. Those distances from 0 are again greater. So we're going the other direction. And we jump over a gap with a union. So we will say from negative infinity, which is all the way to the left, to negative 2, union, jumping the gap from 2 to positive infinity. Or to set up an equation that we would otherwise solve, we would say that the a is greater than 2, like it's written, or means union, that's jumping the gap. A is, to get the other side, we switch the inequality and switch the sign. Greater than 2 or less than negative 2. In fact, usually I'll switch these around just to help out. A is less than negative 2 or A is greater than 2. Because we like the negative to come first, we like to go smallest to largest. And that's also going to correlate the negative 2 with the negative 2 and the positive 2 coming second. So that just kind of goes together better. Although technically the order of the inequality doesn't matter. So now we see the absolute value of 5x minus 3 is greater than or equal to 1. Notice this is different than the problems we solved in B1 in our notes up above, because now the inequality is greater than a number. When it's greater than a number, we will say the 5x minus 3, switch the inequality, switch the sign, is less than negative 1. Or the 5x minus 3, just like it's written, is greater or equal to 1. And we'll solve both of these. By adding 3, we get 5x is less than or equal to 2. Dividing by 5, x is less than or equal to 2/5. Or, solving the other equation by adding 3, we get 5x is greater than or equal to 4. Dividing by 5, we get x is greater than or equal to 4/5. Which means in interval notation, because negative infinity is on the left, we have negative infinity up to 2/5. Or is a union. And then x is greater than 4/5. So we're going to go from 4/5 to infinity for our final solution. So a little different when the absolute value is greater than a number. We do a union. Flip the inequality, flip the sign. Let's try another example. How about we do the absolute value of 3x minus 5 over 2 is greater than 5. And actually, making me think, up here, our previous answer, we have a mistake. Because we've got that or equal to line, we should at 2/5 have a square bracket, and we should at 4/5 have a square bracket. Square brackets when it's or equal to. Compared with example B here, we're not going to have a square bracket because it's just strictly greater than. Again, though, we'll notice because it's greater than, we'll say the 3x minus 5 over 2, switch the sign, switch the symbol, less than negative 5. Or the 3x minus 5 over 2 is, just like it's written, greater than 5. Clear the fraction by multiplying by 2. Gives us 3x minus 5 is less than negative 10. Add 5. 3x is less than negative 5. Divide by 3 to get x is less than negative 5/3. Or, going through almost the identical process on the other side, multiplying both sides by 2. 3x minus 5 is greater than 10. Adding 5 to both sides, 3x is greater than 15. Dividing by 3, x is greater than 5. And so in interval notation, let's do it in pink, negative infinity, bad infinity, negative infinity to negative 5/3, or is the union, and then 5 up to infinity. Let's try one really involved problem. How about we have 5/3 minus 1/6 times the absolute value of x plus 1 over 5 is less than 1/3. Now you might notice that this guy has an absolute value in it and a less than. So does that mean we're between two numbers? Well, we can't make that decision until the absolute value part is alone. So we have to get it alone by dealing with all the fractions outside of it. Well, let's make those fractions easier to work with. Let's clear the fractions by multiplying by the LCD of 6. 6 over 3 will reduce to 2, so 2 times 5 is 10. Minus 6 over 6 is 1. Absolute value of x plus 1 over 5 is less than 6 over 3 reduces to 2. 2 times 1 is 2. Still working on getting the absolute value alone. We have to subtract the 10 from both sides, because we cannot subtract the 1 and combine because those are not like terms. So we have negative 1, absolute value of x plus 1 over 5 is less than negative 8. Divide both sides by the negative 1 because we can't distribute it. And when we divide by a negative, the inequality is going to flip over. So we have the absolute value of x plus 1 over 5 is now greater than positive 8. Which means now we treat this absolute value like it's a greater than absolute value. Greater means we're going to set up the OR. X plus 1 over 5 is switch the sign, switch the symbol, less than negative 8. Or x plus 1 over 5 is, keep it the same, greater than 8. And solve these remaining equations. Multiplying by 5 gives us x plus 1 is less than negative 40. Subtract 1, and x is less than negative 41. Or, same thing on the other equation, we'll multiply by 5 to clear the fraction. X plus 1 is greater than 40. Subtract 1, and x is greater than 39. And then writing that in interval notation, we're going from negative infinity to negative 41, union 39 to infinity. And we have our solution. So with absolute values, it's important to note we're going to have to make a big decision with these absolute values. We're first going to have to isolate the absolute value, get it alone, and then, that's a bad then decide if the absolute value is greater than some number, emphasis on greater than a number, it is an OR inequality with a union. Contrast this with if the absolute value after it's alone is less than some number, less is tripartite, where x is between negative n and positive n. So you're going to have to decide that on each inequality problem. Which one is it? So you can set it up correctly and then solve. Today's homework assignment in 1.8 takes a look at absolute value equations and all types of absolute value inequalities. Practice, practice, practice. Come to class with questions. We will see you then.